you around in the R&D engineering department, and we have a new design being laid out here by Michael Follonier, who is essentially routing all the signals by hand. And this is crucial. This is crucial to the quality of the design, to reduce the electronic magnetic interference, to reject as much noise and interaction between digital parts and analog circuitry, which is here. So the layout of that board is really absolutely crucial, and we're going to spend something like 2 or 3 weeks just to do that design by hand. There's no automatic routing at all, and as you can see, it's quite a well-packed design using components on both sides of the PCB assembly. If you highlight what's on one side, we can see on one side we have all these analog components.
But it's multi-layer?
It's multi-layer as well. So this is one side of the circuitry, and on the other side of the same circuit, we have a number of different digital AD converter, D2A converter parts. This is design being done right now for a product that we expect to launch this year, later this year.
And the interference of electromagnetics is the most
crucial part. As you can see here, every signal, analog signal, is carried like a differential pair. So that any electromagnetic interference has minimum impact on the signal.
Capacitance and inductance.
Inductance, mainly inductance. And then we have ground layers that separate
ground
the different ground layers.
To
ground, yes.
And what is
that procure shielding.
What is the handicaps of that kind of PCBs?
The problems to avoid is, for instance, to have crosstalk between channels. And this can be capacitive or inductive interference between various parts of the design. So in order to have as good as possible or minimal crosstalk, you need to be paying very much attention to how you route your signals across the board.
And the layout is not do and export like an Eagle?
Yes, we import the design here from the schematics. This is the schematics.
Yes.
And this schematic is then turned into a PCB. But we still have to manually place every component where we think it's best placed.
Okay.
All right? So you can see the exercise is even more complex on boards like this. This is typically a very tiny board where we have all the intelligence, all the DSP processing taking place for that new product range.
This is your new product.
This is a component of our new product. As I can remove this, you see this small part here. This is the Z-Man board, which includes a Xilinx chip, which incorporates two ARM CPUs or processors, plus some FPGA, all in one single chip. And this is really very dense circuitry with a very low phase noise clock circuitry on top. And this will be at the heart of many of our new products. And if we go a bit further, we have Loïc Andrieux here doing some
test.
some measurements and checking how the signals look in real, not in simulation,
Yeah.
on existing boards that we are also planning for this new range
This
of
is an
products.
scope, but do you use spectrum analyzers?
We also sometimes use spectrum analyzers, yes, definitely. When it comes down particularly to measuring radiating field or clock jitter, that's also things that...
And he is testing right now the new product? Something of your new product?
Something in our new product, exactly. Which starts to work.
And it is,
It's a fight. It's a fight.
It's very difficult to develop a new product.
You have to have some patience, yes. Yeah. And you need to be stubborn. You need not to accept difficulties. You have to go over many, many difficulties.
It's a trial and error.
It's patience.
It's trial and error.
Yes, of course, there's a bit of trial and error, but most of the things we simulate ahead. But what we find out is not all characteristics can be accurately checked in simulation. There's always a good part of surprise, because the chip, because the way the definitions of how it operates is not 100% clear, makes us discover difficulties along the road, along the path of development at different steps.
In this PCB he is testing, I see that it is right now is finished. So who is assembling the PCB?
The
You
PCBs,
send the design?
we send to subcontractors these PCBs for assembly. Some of them are being sent in Switzerland, some others in various countries, wherever it makes sense to have them produced. Yeah.
But do you use breadboards or prototype
No,
boards?
we design the board and we immediately do a prototype of that board.
You simulate and then
We
manufacture.
simulate and then we manufacture. Yeah.
And how many PCBs, more or less, are necessary until the project is?
Sometimes we're lucky, one prototype and then we can launch production.
Only with the simulation.
Yeah, we do one prototype and then we find one or two mistakes possibly, sometimes even zero. We have been recently quite successful in many new designs, and sometimes it takes two iterations until we are happy to launch production.
And which programs do you use to simulate?
We use various tools to do analog simulation. Typically, we use TINA, which is a tool that is supplied by Texas Instruments. Loïc, what other simulation tools you use for FPGA design and things?
We use Xilinx tools like Vivado,
Vivado,
IOC,
yeah.
the standard tools. And we simulate most of the design like this.
He only does the test, or he makes other things.
Oh, he does the design.
He makes the design.
Yeah, yeah.
So both.
So
both-
if it doesn't work, he has to blame himself first. Yeah.
but only him or both.
Oh, we are a team.
Okay.
We are a team, but certain parts are done just by him, some others by him, and then we put that together, and then we need to make it all work. Yeah.
And you begin doing the simulations and doing the designs.
I do part of the analog design. Yes, I still find little time to take part in the design process. It's one of the best part of my job actually. So it's one of the most enjoyable part.
Okay. So we could see other things.
Yeah, we can see a little bit the other part.
This one is for anything.
Yes, this is where we check typically the Ethernet networking.
The networking.
Yes, with various third-party product. We have Digigram here.
Yeah.
We have direct out product here, and of course our own Horace, and they all are linked to a gigabit switch, which is here,
Yes.
and we make sure that they are all interoperable, because the whole point is to have open, interoperable systems between many manufacturers. That's the key element of networking. We need to be able to talk to direct out talking to Digigram, Digigram to Lavo, etc. It's a complete ecosystem, because one single company cannot do all the products for that market. So we make sure, and we spend a lot of time attending interoperability tests, gatherings. Last two were in Houston, Texas. So we have Nicolas, who is not here today, but
there is a person.
he's
who
part of the team, of the staff team that sets up these meetings, where different manufacturers come together and make sure all their designs and all their products work together and are interoperable on the network. Well, some of our software engineers, among other things, live on the other side of the border, not in Switzerland, but in France. So for them, it's more comfortable to only come 3 times, because it's a long road, 3 times a week. And the other days in the week, they can work from home as a software engineers. That's pretty workable.
Mainly the software engineers.
And they save time, mainly software engineers. Yeah, hardware you need to have a lot of equipment. It's more difficult. Frederick, tell us what you are doing. Tell us what you are doing.
Software development here, currently working in.
You are programming in C.
I'm doing
C++,
C++
yes.
programming, and mostly focused in pure mix development, including the hosting of effects plugins, or mastering parts like publishing formats you can get from production, and yeah, that takes me quite a lot of time.
You program the pyramids?
Yeah.
Only you?
Only no, I'm not the only one involved, but I'm mainly working on that product. Yeah. Yeah.
And it's difficult to program a digital audio workstation?
But it involves a lot of skills, and also with such a product which is quite old, like 25 years old.
Yeah.
It takes also a lot of time to maintain the existing stuff.
To maintain and upgrade.
Yeah. Also, we have to deal with third-party
Plugin manufacturers.
Yeah. Plugins mainly. So yeah, it's quite
And
sketchy.
why do you put the code on C++ and no other language?
I think for what we're doing, we need efficiency is quite important, especially for real-time operating, real-time audio thread. Or we need for such a digital audio workstation like Permix. We mainly focus on offering a lot of tracks at high resolution. So efficiency is really an issue, and I don't think you can achieve such efficiency with another language such as Java or C#. Of course, you could go even further with pure C, but it's hard to maintain.
And who is programming the FPGAs?
Loic and Michael over there.
But they program it in ensamblador,
In
assembly language.
VHDL, in a language called VHDL, which is an abstraction of hardware. I'm too old to do that. I used to do FPGA design, but it was in the
Yes.
early FPGA
And did you
days.
program DSP?
Yes, there's got to be a lot of DSP as well. Yeah. But this year I leave to the young guys now.
Okay.
That's where usually Bertrand is, but you are on a Monday, and on Monday he's not in the office. He's working from his home office in France as well. He takes care also of many software components in PMX, in the Horus and Happy. He does all the control software, basically, the real-time, low-level software that is critical to real-time operations. That is
Low
easy.
level.
Low level, yes. High skill, low level.
Yeah. But it's only for software.
Software, yes.
Not
But
programming.
software that runs on hardware. Yeah.
That runs on hardware.
Yeah, also. Not only on computer, but also on Horus, on Happy. There's quite a bit of software running there.
Okay. And he's programming it.
Yeah.
Okay.
Unfortunately, he's not with us today. So it's a quiet
But
place.
he works in home or
From home, yes.
from home.
Yeah,
Oh, okay.
yeah.
And he have the Horus and Happy in home
Yes,
and test it.
yes. He can check.
Okay.
He can check how software works.
Okay.
He can even via VPN connect to systems we have here and
Virtual network.
yeah.
Yeah. Okay. Okay.
And also we are spending quite a bit of time making sure our software and our products are interoperable with third-party systems like Avid console. This is the Avid X6. Here we have the S3, originally designed by Euphonics team, which then migrated to Avid. So we make sure that these products are working fine with,
Are compatible with
are compatible with PMX as well.
Okay.
So that's essentially here. Maybe we can finish by showing these products here, which are a new generation of products that for the first time in merging history are not accessing the professional world, but the consumer,
Yes.
the high-end audiophile user at home. Because many of our customers who produce these records, these beautifully sounding records, some of them winning Grammys, you know,
Super Audio CD.
Super Audio CD,
Yeah.
surround production in Oro 3D or in Dolby,
Dolby
Atmos,
Atmos, yes.
etc., or simple stereo program as well, you know, tended to tell us, listen, it would be fantastic if users at home could also enjoy the same quality of listening that we enjoy in our studio, in our mastering room, or etc., at home. So they pushed us into developing this new range of product, which are essentially DAC, home DACs, but they are not USB DACs. These are Ethernet network DAC, and that's why they are called NADAC, Network Attached DAC.
Uh-huh.
And we now are beginning this range of products for the home users. And it's growing. Now we have a new product which is called the Power, which includes a linear power. It's the first time in a long time we do linear power as well, and not only switching power.
And why did you ever have problems with switching powers, like a lot of noise in the conductive?
If you're asking me, I did not have problems with it. But again, I think it's a subjective feeling that many people in this audiophile market tend to put more confidence in linear power than in switching power. There has probably been a lot of misconceptions being carried out by various people who maybe implied that by having this high frequency switching, it would deteriorate the sound. This is not something we measure. Particularly, I think that if you are careful enough with your analog design, you should not be susceptible to any sort of interference, electromagnetic or noise from the power supply. If your analog design is carefully thought out, you should be immune to this sort of noise, external noise, including from the power.
But switching supplies?
But it doesn't hurt to have an even better power supply.
Yeah, but switching power supplies could get some dirty into your electrical installation.
You never know what can happen in a large installation where you have not only our own equipment, but other equipment inside, which may not be designed to always comply with a high level of electronic magnetic interference. And therefore, it's safe for certain areas to consider also linear power supply, which we do. We offer the choice basically to our customers.
Okay, later we can see internal power supply.
Why not? Yeah, I show you. I show you on the other side how it looks like.
And this
this is the area of support here, where essentially we have two people full-time in support for the software, for the hardware, to make sure that there is always something ready to pick up a call in case of emergency. If somebody has a problem with installing the software or making it work with a different plugin, etc., we have a very competent team of people, as a matter of fact, that are ready to help on the phone if needed or via email for these sort of difficulties.
So this is the support desk.
It's a support desk here. Yeah.
Okay.
So this is the merging power, which we designed for the home users. And here we could afford some luxury in terms of nice designed linear power supply with a big heat sink here. You can see here the thermal fan, though we have here the transistors, the regulators that are able to dissipate heat, because of course linear
How many watts?
takes more. This is a 100-watt design. Yeah. It's more than 100 watt, but usually it doesn't consume more than 100 watt.
Yeah.
So the design is actually quite interesting because it's a semi-linear. This part is completely linear, and there's another part here which is switching.
Yeah.
Because we don't need, for the computer side, for the digital side, we don't need linear. So we use a hybrid approach with part being in switching mode and the rest for the analog components is linear.
And inside this one?
Inside this one, yes, let's take a look. So here you see the inside of the DAC. The analog part, yes.
And the digital.
And the digital part here.
Yeah.
And this is a pure DAC, but we have also a model that incorporates a server, an audio server, which is yet another computer.
Yeah, and the power supply
Needs to be adequate
for the
to
analog.
power both the analog and the computer side of things. And here you see the Ethernet connection, the gigabit Ethernet connection with the Cat5e cable connecting to the network.
And with something to the magnetic file,
Yeah.
a filter for the magnetic
A
file.
ferret.
Yeah,
A ferret.
yeah. Okay.
Nobody's working, it's late. It's over 6. And even in Switzerland, we start early, but we also have to finish at one point in time. So it's over 6 p.m. now. So my assistant Evelyn is now gone.
And what makes? Well, what is she?
She takes care of all the administrative part, bookkeeping, order processing, invoicing, statements to our customers, telephone. There's a lot to maintain in a company that does hardware, software, and has customers. To.
I think that she helps you a lot.
She helps me a lot, and on top of that, she has good command of Spanish language, unlike me. So whenever we have Spanish customers, she can also help in a direct way. And then we can say hello to Manuela,
Hello, Manuela.
who is very concentrated right now at the end of the day. So Manuela is taking care of all the logistics at merging. And she's relatively new. I mean, it's what, 3 years?
2.5.
2.5, huh? It's not yet 3 years she's with us, but she learned dramatically fast. And she's taking care not only of the raw material, which you see here, that's part of the own inventory we have at merging with integrated circuit chips here, transistors, resistors, capacitors, inductors, connectors, whatsoever. So we have our own stock at all times, so we can start a production very fast, particularly for the components which may have a long lead time, because we sometimes use quite exotic components which not many people in the planet use. Special AD components or D2A chips that we are one of the few companies
Are
using.
these the conversion chips?
Yeah, you see here some of
And
these.
why do you choose these chips instead of others?
Because we feel at the moment they are the best.
In which features? Did you test others?
We have tested almost all existing parts, but when we decide on a part, usually we have very little choice, because we are very demanding customers, because our own customers are very demanding.
Yes.
because we want to do not only standard PCM up to 96 kilohertz or 192 kilohertz. We want to have parts that are able to give the best out in DSD or in DXD at 352.8 kilohertz. And then the choice gets much smaller of the parts you can use for this ultra high sampling rates.
Uh-huh.
And we want, of course, the highest quality in terms of signal to noise, in terms of distortion. So the number of parts we can select from it's less than one hand. So the choice is pretty easy at the end of the day. You know, we have very few manufacturers who are caring to produce these chips because it's not a huge market either. You know, there's not millions of those chips required, unlike those you put in a mobile phone where you produce millions of
And which features fall in love with you of that components?
sorry?
Which features?
The features,
Sí.
signal to noise, distortion, crosstalk, of course, to a certain degree also power supply, you know, if they get too hot, and also number of channels, because we do products which are not necessarily only stereo. We do converters like the Horus, where you can actually capture 48 channels of mic preamp in one single box. So it needs also to be reasonably hungry in power, in electric power.
And what is the reference voltage of that components? 5 volts?
They usually require more than 1 voltage. Typically, those parts need 5 volt and 3.3 volt.
For CMOS.
Digital part and analog circuitry are separate, so you need more. And sometimes you even need 1.8 or 1.2 volt on top.
Oh.
So we need a lot of power supply, a lot of power rails in our designs.
Mm-hmm.
And then at the end, just prior to reaching our customers, Manuela is making sure that each product is perfectly assembled, controlled, checked, no loose screws, for instance. Yes.
No loose.
And making sure that everything works before being packed.
And these are just
These are
for
this
sending
is
package?
part of our local inventory of ready to ship products.
Uh-huh. Great.
Once they get their final test, they get an individual serial number, and then they are ready to dispatch to all the parts in the world, including all the
Cards? The cards?
modular cards,
Yeah.
AD, DAE, Pro Tools, MADI cards, which are stored here.
Uh-huh.
So we should possibly have started with this because right now there is no test going on, but most of the day here we have a sequence of one card after the other. This is, for instance, our latest generation AD card here that is ready to be fully tested with this audio precision equipment here. And what we tend to be doing is get an automatic test of the entire card, go through audio precision. All 8 channels are tested for all these parameters here. They are THD plus N, line level, common mode rejection ratio, distortion, crosstalk rejection, noise in microphone, noise with phantom, power on, etc. And we have to make sure that the entire board, all 8 channels, match a minimum criteria, which is on the right side here. And then we even can split between standard cards and premium cards. Those who are even better than a certain number on all 8 channels are being categorized as premium cards. Because there's always a little bit of variations between different channels, etc. So this is a typical measurement. And here, for instance, some of the specs were not met, so this card is rejected and will not be further shipped. No.
And the audio precision is connected to the computer?
Yes, the audio precision is the computer, and we just launched an automatic program. We can launch it. I mean,
okay.
Yeah. So here you see typically what is being done on every board that gets shipped out. It will be fully tested entirely.
Ah, d'accord. Oui.
Yes, voilà.
Encore. Ah oui, c'est tout. Il y a 2 fois. Parce que...
And it takes about 10 minutes
To
roughly
warm up.
to check a complete card.
Okay.
Yes.
Only
It-
10
it-
minutes.
Yeah.
And must be the equipment warm up with some temperature?
Ideally, yes, but usually it's very fast. The warm up is very fast. Typically, for the phantom power, yes, it's better to warm it up and to have it a bit exercised. But usually, we can start very rapidly the test. So here you see it starts.
Il y avait une
because,
résistance
yeah.
soudée, je crois.
We immediately see that something is wrong with channel 1 here. It is highlighted red. So typically this board would not pass, and we will either repair it or put it away. Yeah. But you see, it takes a couple of minutes to check all the numbers, distortion, noise, exact levels, etc. And red means fail, black means okay for standard, and green means okay for premium. So it's very easy to recognize a board quality like this. And then this test is printed on a sheet like this, and when we deliver a product to the end user, he gets that sheet along with his card, so he can verify that his card was completely.
So it's a
tested.
quality insurance.
It's a quality insurance, yes,
Okay.
process.
Okay.
And what, as you can see, makes most noise in this room now is the
Is
fan
the
of the
relays.
audio precision
The
and the
fan-
relays
the
who
fan
constantly
relays.
change.
Yeah.
These relays have operated 100,000 times already,
Yeah.
probably.
And you use also
It's a
this-
testimony to the quality of the audio precision.
the IG
equipment.
lens
Yes, of course.
for, for what?
Oh, but when we have to identify the root of a problem, the cause of a problem, then we need good tools.
Oh.
So this is a 4-channel, 4 gigasamples per second oscilloscope. So it's really a good device, which we. And also sometimes we come here to test prototypes or new designs, not only production with the audio precision to validate that the design matches our specifications, and then we at sometimes also need a good oscilloscope to check.
And there are some components here to replace and test.
Oh yes, yes, oh yes. We have, as you've seen, we have all the inventory of all the components for production, and we have local engineering products here as well.
And are you soldering SMD here?
Yes. Oh yes. Oh yes. Yes, typically.
With a microscope.
We have here, for the bigger parts, we just need something
Yeah.
like this. This is easy. But when it gets more complex, we have this microscope here
Yeah.
for really ultra small components, yes. So with this, we can pretty much repair or test or improve all sorts of electronic designs, even with very small SMD parts. And at times we use soldering irons, but at other times this is also a very useful tool.
What is this? Heat. Heater.
You can dry your hairs, but we use this to solder or unsolder components also.
It's like the heat wave of
Yes.
the classical S&D.
Yes, but local,
Yeah.
just for small repairs.
Yeah. It's funny.
Yeah.
Okay, so.
So Roberto, I think we did the tour here, huh?
Okay.
It was a marvelous experience for me to
Yeah, I learned a lot with you.
to
Maybe I
discuss
will
with you.
left here my curriculum because I like all of this. I will leave Spain and
You will come to join anytime. Huh?
so thank you very much
Thank you very much.
and see you soon.
See you next time. Bye bye.
Bye.
Thank you.